Good afternoon, everyone. Thank you so much for joining today's Resideo webinar session, where we are going to provide you with an overview of Resideo hydronic products. And we're also going to give you a preview of several of our new water products that are releasing next month as well. My name is Jamie Quanrud, and I'm part of the Resideo Sales Training Team. And on behalf of all of us here today, I'd like to welcome you to our training session. And before we get started, I'm going to just cover a few administrative items before we get into the technical portion of the presentation. Make sure you join us each month as we provide you with 2 opportunities to learn about our Resideo products. So going forward, we are offering these webinars twice each month. So make sure that you visit resideo.com/webinars for more information on these upcoming sessions. And our next session on March 9th, we are actually going to give you a full walkthrough of our 5 new water products that we are releasing in March. So make sure that you register and attend that upcoming session. We're excited to talk with you today about our water portfolio, and then also in the next coming weeks as we introduce our new products as well. Additionally, you can find recordings of our previous sessions on that same website underneath the webinar recordings tab if you are unable to attend the live session. And then on the next slide, for our contractors who are joining us for today's live session and you are interested in earning 1 NATE continuing education credit, make sure that you pay attention here. If you did provide your NATE ID on your registration form, we submit that information to NATE for your attendance of today's live session, and we won't need any additional information from you at this time. However, if you did not provide us with your NATE ID on the registration form for today's session and you'd like to receive credit for attending this live training, we will ask you to email your first name, your last name, your NATE ID, and the date of the session that you attended to homes.university@resideo.com within 1 week from today. This information is submitted to NATE 1 week following the close of each training session, and any requests that are sent outside of 1 week from the live sessions cannot be processed. As a reminder, we can only process requests for NATE credits when you do attend the live webinar sessions, and we are unable to process requests for watching a recorded version of these sessions. If you'd like more information about the NATE program, please visit their website at www.natex.org. And then one quick note before we begin our technical overview, all of our attendees are muted. However, if at any point you have a question during the presentation and you'd like to ask a question, make sure that you use that Q&A feature found in your Zoom webinar controls. We've reserved the last few minutes of our time together today to answer those questions. So as we progress through, you think of something that you want to ask, make sure that you go ahead and use that Q&A feature so we can address it at the end of today's session. We're going to turn things over to Chris Parks, who is our water sales leader for the West Coast. Also joining us today is Mike Ortiz, who is part of our water sales team. He's going to be helping out on today's training as well. So Chris, we're going to turn things over to you.
Thank you, Jamie. And thank you, everybody in attendance. I know it's tough to carve an hour out of your day, so I appreciate everybody that's online to kind of learn about our products, but not only our products, but what applications to use them in, do's and don'ts, etc. So what we're going to cover today is essentially the mechanical room components. So our Resideo portfolio, we make pretty much everything that goes in a mechanical room. We also OEM parts for boilers. The one thing that I always tell people is we don't do the tubing, we don't make the boilers, but we do everything else in the middle, from controls, thermostats, and mechanical room components. So today we're going to go over the mechanical room components. And diving into that, the first couple of pieces that I'm going to discuss are the air elimination water control. So every hydronic system, for the most part, and the one thing I'll kind of lead with is, anytime I'm giving a training, my favorite answer to just about any question is, it depends. There's a lot of different variables. There's a lot of different ways to install a system. Some work, some don't, but you'll hear that answer from me a lot. But when we dive into this, every boiler, for the most part, has an air eliminator, an expansion tank, and some form of water makeup. Now we offer, in our product line, we offer a fill valve and backflow preventer. So we have two different offerings today. We've got call it a better and a best solution. And I'll go into each one of these, but depending on your budget, depending on what you're trying to accomplish, we have a different product that will fit your needs. The first thing that I'm going to talk about is our FM911. So the FM911 is actually a combo product. It's actually two pieces that are shipped in a box that are field installed. So the first part is going to be our VFO6. That is our fill valve. Now, one of the things that we do with our fill valve is it's very similar to our plumbing line in the fact that it has a dial set on the top, meaning if you just twist that red top a few times, you will see the pressure setting in PSI that you're going to set your static pressure to on the system. And I'll talk briefly here in just a few minutes on the difference between static and dynamic pressure in a hydronic system. But in a static, that's essentially what you want to fill the system to with nothing running at all. So what you're going to look for, most common pressures we see today are somewhere between 12 and 15 pounds. But you've got the ability to see a visual indicator as to what your pressure is set at right there at the top. There's a little black plug on kind of the top right. And the piece that I'm discussing is this one right here. So right here, you've got a little plug so you can field install a pressure gauge. That is my favorite spot. If you're going to install one pressure gauge in the system, I encourage you to use it at the fill valve. That's where the water comes into the system, and that's really where it sits stagnant. So this is where you want to install a pressure gauge. If you're going to put it in one spot, you just unscrew this and screw it in. Down here at the bottom, we actually have a shutoff. So what this does is you screw this in and it will isolate or completely close your fill valve. It helps you when you're purging the system. You can kind of open the pressure up and use this down here to open and close to allow very close to street pressure through. Helps with the purging process. We've also got a backflow preventer here, and I've got an image down here at the bottom that kind of shows a cutaway. The backflow preventer that you're looking at, these are called double check backflow preventers. And we call them that because that's exactly what they are. They essentially have two check valves inside of here. So down here at the bottom, this is always labeled vent. This needs to be aimed towards the ground. One common mistake that I see in mechanical rooms is having that vent aimed at the ceiling or off to the side. When this is installed, this vent needs to be piped down to a drain. If you ever get water leaking through here, that is not necessarily a faulty product. That usually indicates there is something wrong with one of these two check valves. So what happens is if everything is in proper order, it's going to come through this strainer. The water is going to come through the first check, go through the second check, and out to the system. If either one of these checks gets sediment, junk, etc., stuck in it, it'll force one of them open and you'll start getting water kind of leaking down through that vent. So it's labeled vent because it's an atmospheric vent, but it basically acts as a drain in proper operation. So you should not see water coming through there. If you do, more than likely there's something that's fouled up one of these two check valves. This is not really a serviceable or replaceable part. If you do get water leaking through, you pretty much unscrew it, go to your supply house and get another one. And then once you go through your backflow preventer, you enter your PRV or fill valve, as we commonly call them in our hydronic systems. And it's basically just a spring-loaded diaphragm that will regulate the pressure. So if your water pressure in the house is, let's say hypothetically, they have a PRV on the house, so it comes in at 60 PSI, comes through the backflow preventer, comes through the spring-loaded diaphragm down to your 12 or 15 PSI from there. That we've had for a while. This one we launched a couple of years ago. So this is our NK300S. It is a beefed up version of the fill valve that I just showed you. So some of the advantages of doing something like this, as I had mentioned on the previous, as sediment comes through and kind of sticks up, it'll foul those products up. This one's completely serviceable. So we have 3 plugs that are on here that allow you to do a couple of things. The first, you can put a manometer on here and actually check the 2 different check valves that are inside of there to make sure that it's operating properly. We've got some illustrations here on the top that show how that's done. So your first check assembly kind of lives in here. Your second check assembly lives over in here. The other thing that's real nice with this is you have isolation valves. So if this does go bad, let's say something gets stuck in here, you get pressure bleeding past it, you get something leaking through the vent down here, you can actually take every part of this apart and clean it, service it, and put it back together. So there's no need to isolate the system, take a part out, run out, replace it. More than likely, it's got sediment that's moved through here, so you can just unscrew this, clean it out, and put it back together. And I've got some illustrations here. These are available in our install manuals that show some of the componentry that's down inside of there. The other thing that we do is we offer this version in a press configuration. So our standard SKU comes with either sweat or threaded. They're actually both in the box. But we do have a separate part number if you want to do press. So this version is available on press, whereas our previous fill valve and backflow that I showed does not have that as an option. And then one thing I'll just kind of point out on fill valve and backflow is the other thing I always teach people, when you're first setting this up, the whole purpose of this is to reduce the pressure into the hydronic system. Once that hydronic system is filled and has run for a little while, you should not need to introduce water to it anymore. So I always suggest your incoming water or your incoming valve to shut this off. What that'll do is if you have a pinhole leak, because I've seen it time and time again where let's say you're doing an in-floor job and a flooring guy pops down floors and hits a nail right through the tubing. What'll happen is it'll actually form a leak-proof bond when that nail first goes in. But what'll happen over time, that nail will actually start to rust out, and then you'll start getting a small leak, which will turn into a bigger leak, etc. So if you isolate your fill valves, again, after the initial fill and you've given it a chance for it to eliminate the air, what'll happen is if you have this shut off and you have a small leak, your pressure is going to drop out in the system, which will eventually either trigger a low loss condition through third-party device, or a lot of the newer boilers have actually got pressure sensors in them. So it will trigger an error. It'll get you a callback out there without mimicking a problem that could become a major, major catastrophe in the home. So I always recommend, it's personal preference, but I always recommend closing this valve, or in the prior slide, have a ball valve before it that you can shut off. Now, one thing I will point out, in certain areas of the country, some jurisdictions have required testable RPZ backflow preventers. Well, there have been some changes. We're excited about this. There have been some changes to some of the code books now. So if we look at our BP 900 and our NK 300S, they are being added to the 2021 UPC and IPC code books. So we've had a couple of areas that City of San Francisco is a good example, where we've looked at getting the NK 300S certified, but it didn't have the right certification and approvals in the code books. Well, they have been added now, so that will be coming out. The one thing I will caution you on, we are typically very behind in the code books. I know a couple areas that are still running off the 2015 code books that exist. So it will be in the 2021 code books. We've got some confirmations on the tables and sections that they're going to be in. The nice thing about this is some of those areas that require testable backflow preventers, and you've been having to install a large, expensive RPZ backflow, this more than likely will be approved. Now that goes jurisdiction by jurisdiction and inspector by inspector, but it is getting into the code books. So more to come on that. So getting into some of the theory and layout behind a hydronic system. I get asked a lot, what pressure should I set my hydronic system? And as I had mentioned before, my favorite answer is it depends. We have used 12 PSI as the norm in hydronic systems for a very, very long time. There is nothing wrong with filling your hydronic system to 12 pounds. What that means is if you've got 12 PSI, and I'm using an example here where a basement lives in a, or I'm sorry, where a boiler lives in the basement. That's not always the case. Sometimes they're on roofs, sometimes they're in other areas of the home. But in this example, I've got the boiler down in the basement at the low point, which is also where it's going to be filled. So let's just say we're filling our system down here at the basement. What this means is if you pressurize your system to 12 PSI right here, well, I guess hypothetically, I'm showing it right here. So if you have 12 PSI here, you're going to be able to overcome gravity. And what that means is at 1 PSI, because we live in feet of head more times than not in a hydronic system, this means that you can go 27.7 feet vertical. So at 27 feet, you will still have positive pressure at the high point in the piping. The problem lies with, what if I've got a building that's more than 3 stories? Because what happens is if you have 12 PSI down here, you'll end up with no pressure above this point. So what we can do is we can increase the pressure to, I'm just going to use an example here, to 15 PSI. And we're going to use a conversion that's very, very common in a hydronic system. So in our different measurements, 1 PSI is equal to 2.31 feet of head. If you don't know that formula, write it down. It comes up all the time because we use PSI for our static pressure and we use feet of head for our dynamic pressure in most instances in the hydronic system. So if you're looking at a pump curve, it'll say feet of head. If you're looking at a pressure fill valve, it'll show PSI. And I'll talk about the differences in a minute, but this is a conversion. This is that you want to know. This is one of the 4 or 5 formulas that come up all the time in heating systems. So if you got to get taller than 27 feet, by increasing your pressure down here to 15 PSI, using that same conversion, I can now go almost 35 feet tall and still maintain static pressure. The key is you have to maintain pressure at the high point. If you don't, you'll introduce a whole slew of problems, and I'll talk about some of the air introduction issues that you can run into. Going along with this, what we're looking at next is the expansion tank. So we talked about water coming in. We got to go through a backflow for safety. We go through a fill valve, which reduces our pressure down to, let's say, that 12 to 15 PSI range. The next thing we're going to hit is our expansion tank. Since our hydronic system is completely closed, what happens is as the temperature will increase in the system, your pressure is going to increase as well. The expansion tank is there to absorb that pressure. I've got an illustration here that kind of shows how an expansion tank works. If you look at, there's a very big misconception of what expansion tanks are also. There's not, in modern expansion tanks, there's no big bladder inside of here. What you have is, if you ever look at an expansion tank, you'll see a ring that kind of comes across over here. That's actually the point where there is a diaphragm attached. So what happens is, in a perfect system, let's say you filled it to 12 PSI, the air pressure would also be matched at 12 PSI, meaning that this air cushion is taking up virtually the entirety of the expansion tank. As the system starts to expand, as the system heats up, you get expansion of water. That's going to push down against that diaphragm to maintain a consistent pressure. And I've kind of got that shown here through some illustrations. The one thing I will point out, you need to double check. There's a little Schrader valve down here at the bottom. Check your pressure before you install it on a system. These all come factory pressurized to 12 PSI, which again, that's kind of the norm that we've used in hydronic systems for a very, very long time. But a lot can happen. It changes in elevation and altitude. I live up near Denver. We're about 5,500 feet. This is not going to come out at 12 pounds if you put a gauge on it in Denver. It'll have a slightly different pressure. The other thing is, if you are to increase your pressure on the water side, you need to match it on the expansion tank. So if you fill it to 15 PSI here, you need to, before you install it, put this expansion tank to 15 PSI, because what you're trying to do is give that diaphragm the full capacity, which is going to allow that full acceptance volume into that tank. If you only have 12 pounds in here and you have 15 pounds on the water side, you're preloading the pressure on that tank. So you won't get the full capacity of the expansion tank there. Going into one other topic I'm going to touch on briefly. I'm not going to go into detail on this because there are entire books and articles that are written about this. But when you're looking at the placement of these products that we're talking about, you always want to have your circulating pump installed after the expansion tank. So if you look at kind of the way I have this oriented here, you've got your suction side here and your discharge here, whereas this is the way that it should be installed right here. And the reasoning is a circulating pump on a hydronic system creates a pressure differential. You're not pumping water up and out like you would with a sump pump or a sewage ejector. You are literally just circulating water out through the system and back. So what this is doing is it kind of creates a Ferris wheel effect, and you're creating a pressure differential. So the problem is if you had this here, let's just say hypothetically this pump, and this is a pretty dramatic example, so this is almost a commercial circulator I'm showing, but let's just say this pump was going to create a pressure differential between the suction and discharge of 14 psi. Well, if you have your system static fill to 12 pounds, when this pump kicks on, you're basically pushing all that extra pressure into the expansion tank, which is going to create a negative suction on the suction side. That creates a lot of problems. It'll actually suck air into the system. If you have any automatic air vents prior to this, it will create cavitation inside the pump. It'll create a whole bunch of problems. So what you want to do is create a positive pressure in your heating system. So you put it on the opposite side, pump away from the expansion tank. That way that 14 psi differential is added to the discharge. And then when it comes back around, it's all basically balanced out here at the expansion tank. So the placement of the circulator in relationship to the expansion tank is critical. So keep an eye on that. I also get asked a lot, what size expansion tank do I need? There's a lot of math that can go into this. I've got a couple of charts I'll show you. There's a couple different ways to size it. Now, when you're looking at mechanical room components, you usually are not going to hurt. You usually want to make sure you size everything appropriately. So you don't want to oversize things, because if you oversize a pump, you're going to end up deadheading it. It won't work within its efficiency range. You'll have all kinds of issues. So you usually want to keep things sized to the heat load of the system properly. The expansion tank is one of the few areas and components that you can oversize to your heart's content. So if you're ever on the verge of wondering if you need to use a Model 30 or a Model 60, save yourself the hassle and just go with the larger one. There's usually not a lot of difference in cost, especially on the residential sizes. It's pretty minimal. It's not worth the call back to go back if it's slightly undersized. So there are a couple ways to size it. I've got some charts up here. This chart right here, this is my favorite chart to use. This shows the water capacity that the expansion tank can handle at different temperatures. And if you look at it, even if you're going in on a service job, it's not too hard to figure some of this out. And there's a lot of guesstimation that goes in. But let's just say you go in and you know that this system has a roughly 5,000 feet of half-inch PEX. There are pipe size calculators that will show you what the water capacity is for different pipes at different pipe sizes. That's what I've got in this chart. So you basically just sit down with a pencil and a paper and you start listing everything out. So you've got your boiler room piping. Let's say you got 50 foot of 1.25 pipe. So you would come over here to 1.25, and we've got different water volumes per foot for type L or type M copper. So you would just kind of guesstimate where that's going to be. Then if you've got supply and return tubing going to remote manifolds, you just add that up. So let's say they got 3/4 inch pipe, they got 6 manifolds. So you would add your supply and return, and here's some estimations if they did it in copper or PEX. And then if it's radiant in floor, you would add up roughly how much half-inch PEX you think they've got. Again, overestimate. don't err on the size of being too small. And then once you get that water capacity, you just kind of find where you are. So, on an in-floor job, I've got some numbers I've listed here for maximum supply temps. So if you're looking at like 130 degrees, you can come over to this chart. So if that water is never going to exceed 130 degrees, a Model 15 expansion tank can handle 58 gallons of water. Model 30 can handle 128, Model 60, 194, and so on. If you do an estimation and you come up with 120 gallons of water, again, don't do the Model 30, jump up to the Model 60. This is my favorite way of doing it. You can usually get pretty darn close on the water volume. So I like using this chart. There are additional charts available. These have been out for a very, very long time. I'm a little leery of some of these, but They do have expansion tanks that are, you can kind of figure out what you need based on the size of the PEX and how much is installed. So if it's an in-floor job, and then they also have, for older systems, let's say you've got baseboard or radiators, some of the old like Burnham cast iron radiators, or even baseboard, it'll tell you how many BTUs the boiler can output, and then which one to go depending on what type they have. So it's using an assumption there's only going to be roughly so much water at this BTU output. So these charts exist as well. I'm not as I'm not as much of a favor of using these as I am actually calculating out your water volume. But it's another resource. This stuff is available. We can get it to you if you don't have copies of it. And then bouncing into air elimination. So this is pretty important. We got a couple different types of air eliminators, and I'll actually talk about a third style combo device a little bit later. But what you're looking at with air elimination is again, this is a closed loop hydronic system, meaning when you fill it, there should be no air left in the system. So what we have to do is when you first fill that system, we have to get rid of all those little bubbles that exist in the water when you first fill it up. So if you turn a faucet on, it doesn't come out perfectly clear. The reason is when you open a faucet in your house, you're getting a mixture of oxygen and water. You don't really see it, but that's the reason it's cloudy when you first fill it. Could be other reasons, but that should be the only reason that water is cloudy. So if you put it in a cup, let it sit for a little while, you'll notice that it'll actually start to smooth out and become much more clear. That's because all the air rises out of that water and air mixture, floats out to the top and comes out. So that's what these devices do, kind of illustrating again the basics, a very, very basic hydronic system. The water comes in through here, kind of balances out of the expansion tank. In this example, it's going to go out through the system, through the valves. You can purge it out here, but once you get this water filled up, my opinion, put a ball valve right where I have this cursor, shut it off, and you should have no more need for water once you get the initial purge done. A couple other things I'll point out. Again, air being the absolute killer of hydronic systems. I've got an example of, it's actually a product called Fernox. You see those two little glasses there, those jugs. What they've done is they put a boiler inhibitor in one of them, and they've left one just with oxygenated water. That's basically, if you look at the one that's brown, that's what will happen to your hydronic system if you don't take care of the air. The other problem is it'll also be very, very noisy. Because in a hydronic system, when everything kicks on, you're moving solid fluid. You're not moving air and water. Air, it's kind of what makes a lot of the noise. It'll also provide a lot of issues. The other thing I did want to point out, there are some areas where people have installed the wrong type of PEX tubing. So there's two different types. And I've got an image there with Uponor as an example. They make an Aquapex and a HEPEX. They both look the same if you're looking at them in the picture. The difference is the HEPEX has what's called an oxygen barrier on it. With PEX tubing, plumbing PEX, the problem with it is it's if you don't have that oxygen barrier, you will actually have oxygen molecules creep through the PEX into the water stream, and you'll have all kinds of issues from there. So something to look into, just make sure that you've got the right type of tubing. If you go out to a job and you see mud basically in the system, I've seen it that bad before. That brown image there in the jug is a good example of that. Chances are you may have some issues that can't be easily repaired. And as air goes into the system, it can provide, again, it's noisy, can provide air blocks, etc. But the other thing that you will have to take into account is you will have to find a way to eliminate all ferrous materials, or you will have problems. So I've got an example here of some of our new pumps that are coming out in about a week, actually. And you'll see I've got one with a stainless steel volute and one with a cast iron volute. If you don't get rid of the air, you got oxygenated water, you got to keep an eye on, you got to move all that stuff over to stainless steel, unfortunately, or bronze, if you've got the option for that too. And again, we've got another training coming up here in about 2 weeks to go over some of our new products in more detail. So the two types of air eliminators that we have. First, we have an air purger. Field terminology is a lot of times called an air scoop. And what this is basically a big chunk of cast iron that's hollowed out and has these little veins inside of them, basically. And the theory behind it is if you have enough straight pipe, the air is going to rise to the top of the pipe, which then as it travels through, I'll get my laser pointer out again. So as the water comes through here, these air bubbles are going to float to the top. And as they enter this air scoop, it's going to basically get scooped up through these veins and driven up to the top. So then you put an air vent. Usually you see an automatic air vent that's installed here at the top port, which is going to basically activate this float, purge the air out as it gets enough air bubbles. These work okay. They've been around for a very, very long time. They're very inexpensive. They're also very finicky if they're not installed correctly. You cannot have the velocity of your piping exceeding 4 feet per second, because if you do, the air bubbles never get a chance to rise up to the top. So if your velocity is coming through too fast, it's just going to keep the mix. It's going to keep the air mixed in with the water, and it's just going to keep pushing it right on through. The other thing that you'll have an issue with is if you do not have enough straight pipe in front of here, you usually need like 4 times the pipe diameter or minimum of 18 inches before, because if you come up straight, and I've seen these installs all the time, if you come up straight 90 right into this, the problem is that water and air is too turbulent as it exits the 90, and it never gets a chance again for those air bubbles to float up. So they work okay. They're not real effective, but they do work. These are great on cast iron boilers with baseboard. They work fine for that, as long as you have enough straight pipe in front of it, enough straight pipe out of it, and your velocity is fairly low on the system. What we've seen a giant migration to in the industry over the last 10, 15 years is what's called a microbubble air eliminator. So we have our SuperVent line. We've had these for a long time. This is actually our 2nd generation. Our 1st generation used to vent vertically. And the problem we ran into is, especially on glycol jobs, there would be issues with the float assembly sticking and basically leaking through that. So our engineers did some magic inside of here, vented this through the side, and we don't really have issues with glycol anymore. But the way this works, same type of thing. Water comes through here, but what we have is a little coalescing media device that's going to attract those really small bubbles. And then basically when enough of them collect as they pass through, they form bigger bubbles, and those bigger bubbles float up to the top. It's got another float assembly right here. And basically the way the float works, and there's enough air bubbles here, it's going to push that float up, which is going to activate the assembly inside of here and bleed all the air out. When enough air has exited, it actually pushes the float down. So the air bubbles float up here and push it down. Once enough is satisfied, it basically just closes back off and everything comes back out. These are much, much more effective at collecting air than, say, an air scoop. And the reason we've seen a big transition to this is, one, you can put this in a much tighter spot. So if you need to come up and 90 almost right into it, you can, it'll still work. And 2, the micro bubbles are what's causing havoc with a lot of the high efficiency, the modulating and condensing boilers. So this gets rid of all those little bitty bubbles and allows it to continue on. The other thing that's nice with these, the serviceability of them is real easy. You've got a float assembly up here. You unscrew this, it's the same repair part for every single one. So it doesn't matter if you got a 3/4 air vent or a super vent or a 2-inch super vent, it's the same size and same repair part. So from a serviceability standpoint, very, very easy. And usually the only time we see these gummed up is if it's with glycol. The reasoning is, if anybody that's ever messed with glycol, for those of you that don't know, it's a freeze inhibitor. It becomes very tacky, very sticky when it's introduced to oxygen. And what do you have going on inside of this float assembly? You got a whole lot of oxygen. So you basically have a glycol mixture that's introduced to oxygen and a float assembly that needs to ride up and down. So that you can run into some issues there. It's usually glycol. It's also the reason that if you have standard air vents in a system, on glycol systems, you see these things getting replaced every 3 to 5 years, because the glycol gets in and just basically gums them up, is what happens. Not nearly as common or quick a failure rate on just pure water. The one thing I did want to point out, I love these air vents that we offer. I know we've got some Canadian people on the call today. We sell a lot of these in Canada because you guys have got much colder temperatures than we see in the US. And the beauty of these two air vents, the EA79 and the EA122, is that they're serviceable. So like this one, for example, that's got an 1/8" connection, which is the most common size that you see on most residential and even light commercial, is that you can take, there's a little threaded piece right here. This unscrews and it gives you access to the float assembly. The other thing that's real nice with these is both of them, if you twist the base, so it's easier to show on the EA122 where you've got the black going into the brass. If you twist the plastic piece, it will actually activate an isolation valve. So you don't have to put a separate valve here or drain down any of the system. You just twist this 90 degrees, unscrew the top, service it, put it back, open it back up, and you're back in service. So these are great. I highly recommend this one if you've got glycol systems, if you're replacing standard air vents on a regular basis. This will make your life much, much, much easier. Now we've talked about the main components that go with pretty much every boiler. The one exception is on the fill valve and backflow side. Some areas, if you are using glycol, I've talked about that a few times, you're not going to use this product. If you're using glycol, you're going to have a glycol feeder. Basically a big tank that's got a little pressurized fill assembly on there. So we've got, so what we have here is if you're doing that, we did bundle these into a, we did bundle these into a kit, and the kit basically contains all the components at a lower cost.
Yeah, we're good. No, yeah, I haven't even released that yet. I don't know how it got released.
Sounds like we've got somebody off mute. So if you want to make sure that you're muted so that we can continue on with our presentation, that'd be awesome. Thank you.
Thank you, Jamie. I was trying to figure out how to do that. Yeah, so we offer this in a kit. It's much less expensive. Again, diving into the new products and training in a couple weeks, we do have a full press kit available now. We are going to be launching this in 1 week. So we have a press air eliminator coupled with a press fill valve and backflow, and then the expansion tank. So if you look at the costing, if these are components you're putting on your systems, you can save a pretty good amount of money by buying them in a kit. So something to look at. Check with your local Resideo reps on that. The other thing I want to talk about is hydraulic separators. So this is a product we've been asked for a while. As modulating and condensing boilers continue to grow in popularity, this becomes a really nice solution and a nice product for you. When I used to design a lot of systems, what I would do is I would typically put these with every boiler that we sold. And the reasoning was it takes the place of a couple components. It makes the piping much easier. It makes it much faster to install because you've got less connections. And now the beauty of it is we've got, with ours, we have a magnetic element inside of here that'll collect some of the ferrous metals. So if you're doing a boiler replacement, in my opinion, and I'm very opinionated, but in my opinion, this is a no-brainer now, because you've got the ability to collect any ferrous metals that may exist in the system. So if it's old cast iron radiators, if there used to be a cast iron boiler, etc., any of that's going to get stuck here on the magnet and purged out. As we're seeing more and more migration to variable speed pumps, the way those variable speed, and this, the reason this has become more of an issue, variable speed pumps are basically giant magnets. I remember when we're finally introducing ours, but they're essentially a giant magnet on the motor now. We call them permanently magnetized motor. That's how a lot of the ECM technology works. So you don't want all that metal sticking into the pump. You guys can imagine why that is. That pump will not last very long. So by having a giant rare earth magnet in the system, you've got somewhere for all that stuff to kind of travel through the system and get stuck on. So it's going to protect your pump. It's going to protect the system. It's really a great product. I'm a very, very big believer in them. And if you get into systems with more than one boiler, it just makes the system work that much more effectively. Going into what we're going to be offering, again, we're going to have a much deeper dive into these products, but just real briefly, what a Hydrocept does is it decouples the boiler from the system. When you're looking at the modulating and condensing boilers, the boilers do not have the same amount of water that they used to. Even the fire tube styles have a lot more water in them than they used to, which makes them much more prone to flow issues. Our offering, we're going to do 1 inch all the way up through 6 inch flanged. We've got different tailpiece connections. And these are also launching on March 3rd, I think, whatever the first Monday, it might be March 1st. But what this is going to do is this kind of rounds out our portfolio and provides a solution for you guys that are doing any kind of near boiler piping. So if you're installing closely spaced tees, this is a great product to use in place of that. And the way this works is when water comes in, again, you've got your boiler. I'm going to keep the orientation this way. So let's say hypothetically, we've got our boiler on the left side, and this goes out to our zones, whether it be one pump with zone valves, or you could have 6 pumps if you're zone pumping. You put your boiler over here and your system over here. As the water passes through that transition point, a couple of things happen. When you go through the hydraulic separator, there is a major, major velocity drop that takes place. So if you're entering, I'm going to use my favorite 4 feet per second. So let's say hypothetically your velocity is 4 feet per second. When it comes through the Hydrocept, because of the dramatic change in diameter and size, your velocity drops inside of this to roughly maybe a half. So you're going to go from 4 feet per second to maybe 0.5 feet per second. There's some math on that. I'm going to keep this kind of high level. Because of the dramatic drop and change in velocity, a couple things take place. 1, the air bubbles rise up. 2, all the dirt is going to fall out of the water stream. That's just because, again, of that major, major velocity drop. And then it basically comes through and enters back through. So we did have a plate installed in here to kind of help collect those air bubbles. So just in case you're kind of pushing the limits of that velocity a little bit, this will help collect those plates. The air will stick to it, rise up kind of like our SuperVent does. And then to help with the dirt collection, we have that magnet inside of here. So the magnet comes with a dry well. Got an image of it right here. So the dry well goes in, this magnet slides inside of it so that when you service it, you don't have to drain any of the system down. You basically just unscrew the magnet from the well, pull it out of there. You need to make sure everything is off, and then everything's going to fall to the bottom. And then you've got a little blowdown valve down here at the bottom where you can just kind of burp this stuff out real fast. I have seen issues, and again, you're going to start seeing it more and more as variable speed pumps become more common, but the ferrous metals are becoming a major problem. So this magnet's an incredible solution. But again, it takes a point. So by installing this, you no longer need an air eliminator. You don't need anything to capture the sediment. I see people that install Y strainers or even some of the bigger dirt separators. This will take the place of that. So it's kind of 3 products in one. It's closely spaced tees, air elimination, dirt elimination. I guess you could say it's 4 in 1 because it's got a magnetic separation as well. Great product. I used to sell these with every single boiler, or at least quote them out with every single boiler. And I've got a little cost comparison here where you can see, yes, it is a somewhat expensive component, but when you compare it to what it costs to install an air separator, a Y strainer, and closely spaced tees with labor, it ends up kind of being the same cost. So I'll show you that. But the way it works from an operational standpoint, again, it decouples the boiler and the system. And the big reason is with the newer boilers, the ModCon boilers, this may need 5 gallons a minute, whereas your system is only requiring a half a gallon a minute, or vice versa. So what happens is, let's just say hypothetically in the first example here, we have 5 gallons a minute come into here. And let's say in the rare instance that our system required exactly 5 gallons a minute as well, that water would pass right through here. So it would operate almost like a full flow boiler. But 99.9% of the time, you're going to have varying flow rates on either side of this. So what you're looking at is, let's say this boiler in the example I just gave you, 5 gallons a minute coming through this first side. But let's say your system only needs 2 gallons a minute. What's going to happen here is if you enter at 5 gallons a minute, your system is going to pull 2 gallons a minute out. It's going to come back at 2 gallons a minute because, again, that pump is over here, decoupled from the primary loop. So you're driving 2 gallons a minute through this side, essentially. But because the boiler is driving at 5 gallons a minute, you're actually mixing the flow through here. So 5 gallons a minute entering, you've got 2 gallons a minute coming out this side, 3 gallons a minute coming back here. They meet back up, deliver 5 back to the boiler. So that allows you to do 5 gallons a minute, 2 gallons a minute, while capturing your air, dropping your dirt, and capturing your any kind of ferrous metals that are in there. The opposite can take place, although it's not quite as common. Let's say you had 2 gallons a minute here and 5 gallons a minute over here. Same sort of thing. The only difference is the way that the flow is being merged through here. So here you would have 2 gallons a minute on this side, coming in, mixing, coming back and going back out. So really, really neat product. Takes the place of closely spaced tees. I'll give you this example. So I'm not going to go into too much detail, but closely spaced tees, what they do is decouple the system. So anybody that's been installing ModCon boilers or is familiar with the layouts knows that there's a lot of particulars for this. And I've been to a lot of job sites. I've seen a lot of people do it right. I've also seen a lot of people do it wrong. The idea of explaining closely spaced tees is subjective. I have seen closely spaced tees that are 3 feet apart. And the whole purpose of keeping them close is because it creates no pressure loss, which allows an independent flow through either side. You can kind of see this makes it much easier to install, eliminates the need for an air separator. We kind of play that game of what do you see missing from one side to the next. And yeah, I mean, again, great product. Now, what I do hear a lot is, well, I like the hydraulic separators, but they're expensive. I've got some rough costs here. Get with your local Resideo rep if you're a distributor, or if you're a contractor, reach out to your distributor to get pricing. These are just examples. But what you're looking at is if you look at an air separator, it's 130 bucks, whereas a Hydrocept may be 320. So the first initial inkling may be, well, this is a really expensive product. Yes and no, because if you look at what it's going to be doing is it also does dirt collection. So I went online and I found price for an 1.25 inch Y strainer, just a sweat. So it's kind of a cast brass Y strainer. They're kind of spendy. If you had like a true dirt separator, this would actually be closer to 135 bucks. But just for comparative sake, let's just say it's $75. It's priced for one I found online. If you look at a couple 1.25 inch tees at 12 bucks a piece, you're $25 for those 2 tees right there. And then if you look at the labor, so I'm going to pause here and give a disclaimer. When you look at labor rates, there's a lot that can vary. I mean, you've got significantly different labor rates from, let's just say, Tennessee to California, in Canada as well. So there are lots and lots of different labor rates. But I did pull a somewhat national average for what a labor rate would be charged. And then there is a national trainer that does a lot of training for plumbing who says the average time, again, there's going to be people that are faster, people that are slower, but the average time for sweating an 1.25 inch joint is roughly 9 minutes. That includes the cut, the cleaning, the prep work, the flux, the sweating, etc. So assuming those pieces, that's where these numbers came up from for labor. So maybe less, maybe more. But if we look at 10 sweat connections, so that's each side of your T's, and then a couple extra 90s that you're going to have in there that I don't even remember. You're going to have your 2 connections here on the air separator, 2 connections on a Y strainer, which I don't have in the image, and then all your 6 connections here around the T's. So if we look at that, and realistically, you're going to have a couple extra 90s as well, so that aren't even included in here. But looking at that, 150 an hour, 9 minutes per joint, 10 joints, you're looking 225 bucks. That would be a labor charge. If we come over to the Hydrocept, much more simplistic to install. Again, the cost of the product is more expensive, but look at our labor cost here. So instead of 10 joints, we have 4. We got 1, 2, 3, and 4, just on either side of it here. So 9 minutes per joint, 150 bucks, $22. So you're looking at a fraction of the cost on labor. And if you look at adding all these components up, $459 versus $410. Although the price is more expensive here, it actually ends up being cheaper to install. The other thing that doesn't even come into this comparison, we're still adding a magnetic piece to this system as well. So for a lower cost, you're adding a magnet. And the one thing that I have seen is labor is still very, very hard to come by right now. You can now control your labor rate. You can be in and out of the job a little bit faster as well. So I just kind of wanted to bring light to some of the comparative on the pricing piece, because yes, these are more expensive. I get this all the time. However, look at the comparative here. Even if you pulled this Y strainer out, because I know a lot of people don't install any kind of sediment or Y strainer or dirt separators. Even if you pull that out, you're not much different in the cost there. So I like to show that as a comparative. Again, labor rates vary time. I've seen some guys that can knock out a joint in 3-4 minutes, but that just kind of using some averages there. I did want to bring light to, we have a brand new website. We've been juggling ever since our spin from Honeywell. We've been juggling about 3 different websites. So I am very, very, very happy to say we have a landing page now. And I've got the web address up there. It is still kind of in the works, but I have been using it myself, hugely improved. You can actually find images, you can find product information, etc. So this landing page here, this new website, take a look at it. It's having content added to it every day, but it is live, it is active today. And then what I want to do today is what I want to do now is just bring light to questions. So I know there's been a couple questions asked through the Q&A button. So go ahead and ask them. And we have a couple of questions that get asked to us as Resideo reps on a fairly regular basis. So what I'm going to do is I'm going to have Mike jump in now. I'm going to ask some of the questions that him and I get quite a bit and have him answer them. And then I've got another slide here with images, and we'll just keep taking some of these questions. So Mike, and I don't know, Mike, if you got an introduction. If you did, I'm going to do it again. So Mike is our water inside sales rep for all of North America. He lives fairly close to me. He lives down in New Mexico, covers the whole country. So he's provided a lot of the images that you see, like the cutaway drawings. He's building a Visio library so that we'll have Visio templates and stencils available for anybody that does designs using Visio very soon. And he's also got a lot of experience in the industry as well. So Mike, I am going to call you up. I'm going to ask you some of these questions. So Mike, first one I get all the time. How do I check the pressure in an expansion tank?
Thanks, Chris. Typically when we ship an expansion tank, it leaves the factory at 12 PSI. Now, depending on what part of the country it's going to, there's always some variation in altitude that may impact that. So putting a gauge on the bottom of this thing when you get it, just to verify on the little Schrader valve, is critical, because you could be plus or minus 3 or 4 PSI either way, and just from, again, where its destination is. Now, if you walk into a system and it's already got an expansion tank on it and you're curious about what that pressure is, you need to isolate that tank from the system and to get an accurate rating and make sure that your pressure is what you're expecting.
Thank you. And I love this one. How do you know if it's failed?
We walk into these mechanical rooms and the first thing we see is TMPs going off and the system gauges are not reading what we expect them to do. And what we find a lot of times is you can go straight to the expansion tank, knock on it a couple of times. If it sounds hollow, probably okay. If it sounds solid, more than likely we've reached that bladder, which is what the failure is. And we now have no diaphragm in there regulating the pressure. So again, isolate it. And if you go to unscrew it, make sure you're ready because it's probably going to weigh about 10 times more than you expect it to weigh. And that's a good indicator that it's time to change it.
Absolutely. And I think I already touched on this, but if you want to bring on it, touch on it again, how do I service the air eliminator? And I think I was specifically talking about the SuperVent there.
Exactly. We've got one of the few that are field serviceable. I believe one of the questions that came up on the Q&A is, what is that kit number? It does have a separate kit number. Chris mentioned earlier that we used to have a top vent on our SuperVent, and that also has a repair kit available for it. So you can get with your distributor, and he can give you those kit numbers and order those for you as you need them. The other thing to take a look at is when you do check your air eliminator is look at that coalescing media when you have it open. Just make sure it's not filled up with gunk or Teflon tape or anything that may have come in as debris into the system, because that is a point where you can get some of that trapped.
Absolutely. And what do I do if I get this call a lot. I think we touched on it, but I get this one a lot. What do I do if there's water coming out of the vent port on the backflow preventer?
Well, by the sheer nature of a backflow preventer, this is exactly what we want to see it do. It's a protective device. We want to make sure it's not leaking back out into the potable water in the rest of the house. So if we see stuff coming out of the vent, it's probably time to change that out. Either, like Chris said earlier, either we've got something stuck in one of those checks, or one of those checks has actually got something physically wrong with it. But at least, if we see water coming out that vent, we know it's doing its job.
And I don't think I touched on it. What is the service process for the hydraulic separator? And I think the question that I've had a few times is, well, it's cool that it collects dirt and air, but what do I actually do with it?
Again, these kinds of devices are natural service contracts. A lot of times with the newer boilers, I think people have gotten used to over the years with cast iron high mass boilers of, set it and forget it. But with the fire tube and water tube boilers now, they require an annual service. So as part of that, with a hydraulic separator, we can probably minimize the impact that the system has on the system and on the boiler side of things by servicing these things annually. On the hydraulic separator, like Chris said, shut down your circulators. If you can isolate it with the valves, that's ideal. And at that point, you can unscrew the magnet and open the bottom drain and service out any of the debris or iron ferrous that the magnet had picked up, because it'll fall off of the well and fall to the bottom of the system. So it's really actually a pretty simple maintenance to do that annually. Depending on your water, though, it may be something you do twice a year or teach your homeowner to do.
And last but not least, does the magnet need to be replaced over time on the hydraulic separator? Or is there any reason to replace the magnet?
Actually, there shouldn't be. These aluminum nickel cobalt magnets is what's in there. And they're actually ideal for high temp situations. Because it's in a well, minimal corrosion. It doesn't really get exposed to the elements that the rest of the components in the system do. So typically it should have a pretty long life, and it shouldn't be something that ever needs to really be replaced.
And thank you, Mike. So what I'm going to do is we've got a couple questions that are live here. I will go through a few of these. I've got a question for, can I use multiple tanks on a system? I think we're talking about the expansion tanks. The answer is yeah, you can. When you're doing that, and I think that goes into, was it size large enough? So let's say you got a system that the expansion tank's not big enough. You can do multiple expansion tanks. It's usually a good idea to keep them exactly the same size. But usually what you run into is when you actually break down the cost of adding a second one versus, let's just say, taking that one off, using it on a different job and putting a bigger one in, it's usually easier just to put one expansion tank in there. And then I've got a question here. How do you size the Hydrocepts? Great question. They are sized, 99% of the time, they're sized on pipe size. And you're making the assumption that the system was designed properly. So let's say you got an 1.25 inch line. Almost every time it's just an 1.25 inch hydrocept that goes in. The key is the velocity, which is really going to be driven by the circulators and the pipe size. So you want the velocity to be less than 4 feet per second. But that I got to go with most of the time that's already taken into account with proper system design. So it's not an issue. So usually just match pipe size, but I guess the kicker is make sure it stays under 4 feet per second velocity. I've got a question here. Is there a port towards the top of the hydraulic separator above the magnet? If so, is there a well so a temperature sensor can be placed there? So two-part answer for you. There is a port there. However, it is not an NPT thread. It's actually a straight thread. So we don't have a well for that today. There's a chance that we may bring that into our offering, but what I've seen done on a lot of these, and that's only on the residential size, I think the flanged configuration, so you're 2 inches and larger, I believe those don't even have a port. But usually what we see is, let's say you're going to put a boiler system sensor. The Hydrocepts, the other thing I didn't bring up, they do ship with insulation, which answers somebody else's question on there too. Usually you just take that sensor and strap it to the steel body and then put the insulation around it. So it doesn't go directly into the water stream, But if you look at the dry well versus putting it on the body, the actual thermal conductivity is going to be pretty minimal between the two of them. So it's usually fine just to strap it to the body and put insulation over it. That'll eliminate the ambient temperature read. And then I think I've got one here about temperature loss. I think that's also referring to the Hydrocept. And no, not really. It ships with insulation. Some people choose to use it, some people don't. But no, not really in temperature loss. No more so than you would have on your piping already. So if you're not insulating your piping, it would be no different. And I'm going to do these pretty quick because I'm running up against time a little bit, but I've got a question here related to the air scoop. I specified a minimum of 18 inches before it. Is there a maximum length? Great question. No, there is no maximum length for straight pipe on an air scoop. So if you can give it 10 feet, give it 10 feet. The more straight pipe before an air scoop, the better it's going to do at collecting air. It gives it more chance for all those bubbles to float to the top. And again, the SuperVents, the micro bubble air eliminators, that's a non-issue. I've got a question here. How does the hydraulic separator affect systems that already have manifolds or closely spaced tees? It will actually take the place of closely spaced tees. So if you're replacing a boiler that has closely spaced tees and it was installed properly, so they have enough straight pipe before the tees, enough straight pipe after the tees, they are close enough, etc., you wouldn't really need to put one in unless you wanted to just cut those tees out and put a magnet in. I do know a lot of contractors that will, when they do a boiler replacement, essentially replace almost everything you're looking at on the screen there. So they'll replace the expansion tank, fill valve, backflow, air eliminator, and or Hydrocepts. So they kind of look at that as a boiler package, because if you're putting a new boiler in, you don't want to be held accountable if, let's say, the air eliminator isn't working right, or if the expansion tank has got something wrong with it. So a lot of people just replace all that stuff together. Should you install, got another one here, should you install dielectric unions on the Hydrocept and copper systems? No, actually there's no need to. So the one thing that's not really showing here is this is the base. So what you do is you buy the Hydrocept, and then we sell the tail pieces in 2-packs. And I'm looking just at the residential model here. We have a flange version with ANSI flanges for the bigger sizes, but on the smaller, the 2-inch and below, what you're going to do is you're going to buy 2 tailpiece kits, and we offer them in sweat, threaded, or press, and they basically screw right onto this union. So there's no need for anything else here. This is already basically done for you. So let's say you're going to get press connections. You basically buy the press kits. You would buy 2 of them because we sell them in 2-packs. So the union would go in here, thread to this, and on all 4 sides. So pretty easy to set up and get going on that. And the reason we're doing 2-packs instead of buying all 4 is, let's say you've got an old cast iron boiler and you've got iron pipe coming into this side, and then your system's copper, or vice versa. You can do threaded on this side and press on this side. We're kind of letting you create your own Hydrocept, essentially, from a connection standpoint. And let's see, Hydrocept by flow rate and MBH you want to move. We have that posted. I don't have, so there's a question here about the flow rate and BTUs that you want to move. Flow rate's a lot easier to select off of. We do have maximum flow rates that are published as a general rule of thumb not to exceed. When you look at BTU capacity, it's becoming more difficult. We used to size everything off a 20-degree delta T, which basically meant you took your BTU load and divided by 10,000, and that would be your flow rate. But with variable speed pumps, more efficient system designs, we're starting to see more trends towards 25 and 30-degree delta Ts, which dramatically changes your flow rates. So the Hydrocept, I would size it off of flow rates, not BTUs. And thank you. I got lots of questions still coming in, so I'm trying to get through all these. Keep them coming. I've got a question here for the NK300S, if it is CSA approved. I don't know. I'll have to check the submittal document on that. Mike, do you know offhand?
It does not list CSA.
It's not CSA approved. Okay. And I will say, though, to that, we are getting additional certifications on them still. Some of the certifications take a very, very long time. So if it's not on there now, we may have it in the future. And I've got another question. Why can't you use the NK300S with glycol? Great question. We're actually trying to, well, I can't speak to that. Typically, they're not used with glycol because you're going to use a secondary tank. And those tanks are called glycol feeders. So if you, the problem is, keep in mind, our NK300S is a backflow preventer combined with a, think of it like a pressure reducing valve. We call it a fill valve, but it's essentially a pressure reducing valve. So it has to take a higher pressure and step it down. So if you were to basically plumb into a tank that was filled with glycol for water makeup, you would have to find a way to pressurize that tank. So could it be done? In theory, it could, but by the time that you spent so much, by the amount of money and time you're going to spend building a pressurized tank with glycol and water, it would just be cheaper to buy what's called a glycol feeder, which is essentially all that stuff all in one. We don't offer that today. It's a product that it's a good product for glycol, but I'm a big fan of not using glycol unless you absolutely have to. There's a number of reasons for that I could probably do in a different training class, but I only like using glycol where you have to. So if you've got pipes that run outside, if you've got snow melt systems, if you live in an area where your temperatures get very, very, very cold, but like even in Denver, I promote contractors not using glycol unless they have to. So yeah, basically you would use a glycol feeder, not a fill valve and backflow. And I got James, where would you add a second tank? Great question. So on the expansion tanks, let's say hypothetically you put in a model 30 and it was a little bit too small. And the reason you would find that out is, one, you would disconnect it from the piping. You would make sure that your pressure is set correctly to the static fill. So that's the first thing you want to check. Unfortunately, you do have to unscrew it from the system. So you take that expansion tank off the system, put a pump down there at the bottom on that Schrader valve and pump it up to, let's say your static fill is 15 pounds. Make sure you have 15 pounds of air on there. Let's say it is undersized. You would take that line. Honestly, you could be anywhere on the system as long as it's before a pump. And what you're going to do from there is basically just put two of them in parallel. So I had a couple drawings in the presentation where it comes off the SuperVent and then down into the expansion tank. You would basically just put a T there and put equal distant piping between the two expansion tanks.
All right. Thanks so much, Chris and Mike, for walking us through these questions and for great training today. And thank you to all of our attendees. We do appreciate your engagement with us on the topic of hydronics. You submitted some great questions today, so thank you so much. We're going to wrap things up today with just a few pieces of additional information on the trainings that we have available. We value our relationships with our contractor and our distributor partners, and training is an important part of providing information to you, and you've asked for more training. So we have recently launched an online digital training portal where we are publishing in-depth technical and sales trainings for our customers. So you can access this training portal by visiting the training page that's on our website, on our Resideo Pro website. And the first time that you attempt to visit this online training catalog, you will be asked to create an account. And then going forward, you'll log into your training account to access any of these online trainings. And currently, we've got about 15 online learning modules that are available, including some modules that we recently launched on our T10 thermostat, as well as our Prestige IAQ thermostat. And we've got topics ranging from all over our portfolio, including technical and sales training. So we encourage you to enroll and take those as you have time throughout your week. We are adding more trainings every month to this online training portal. So make sure that you check back often to review the most up-to-date training modules that we've got in there as well. And also, if you are a Resideo Perks member, you can receive training credit when you enroll and take these online training courses as well. We're very excited to announce this online training portal to our training offerings for all of you. And then as a reminder, we are continuing to offer the customer webinar series twice each month. So make sure that you join us for our next session on Tuesday, March 9th, where we are going to cover all of our new water products that Chris teased for us today. So please visit resideo.com/webinars. Underneath the plumbing or HVAC tabs, you can find more information on our upcoming sessions, as well as the recordings of our previous sessions as well are listed underneath the webinar recordings tab for your reference at a later time. One last reminder for our contractors who did not include your NATE ID on your registration form and you would like credit for today's session, send an email with your first name, your last name, your NATE ID number to homes.university@resideo.com within 1 week of today's live webinar session to receive credit for attending this session. And then two final things to note. Once our training session ends today, you will be prompted to complete a survey regarding our training. Please take a few moments to provide us with your feedback on the training that you participated in today. We are very interested in your feedback on not only today's session, but we also use your feedback to help us create future training. So if you have topics that you want us to cover, make sure that you include that feedback in the survey because your feedback is important to us. And then finally, you will be receiving an email from us in just a few days that includes some follow-up information on the hydronics products that we reviewed today, as well as a link to the website for information on our future webinars. And we look forward to having you join us for our next training session on March 9th at 2 p.m. Central Standard Time, where we are going to be covering our 5 new water products. Thanks so much for joining us for today's Resideo webinar session. Have a great day, everyone.